Hi everybody, welcome to another video in differential equations. Section 5.2, differential operators and the elimination method for system of differential equation. So, we will write the derivative using the d is called the operator, a differential operator for y. Now, because that's just the derivative, now we just write derivative. In that case, we define the n-order differential operator. It is L. Actually, it is not the capital L. It's more like or script L. But later on, we might have another L. So let's just write as in capital L. So this is a series, kind of like polynomial, where d acting as a variable. Of course, d is the derivative. Of course, d to the n power is the n-order derivative, and then so on. So for example, if we have L is equal to x squared d squared plus 2x dx plus x to the fifth applied to a function, we cannot just have the operator by itself. That will apply to some function y. Then we just have the second derivative of y times x squared to x times d times y to the derivative of y times 2x and the function times x to the fifth, and then we take derivative. That's what we have. And since this is just a sum and d is the derivative, the properties are inherited from the derivative. The linearity, the sum of the derivative is, the derivative of a sum is the sum of derivatives, and then there's a constant multipliers can move it outside. So that's just properties of derivative. Right, now let y be a function of t, so that d plus 1 times d plus 3 is the same as d plus 4d plus 3. So easily we just have d plus 1, d plus 3. Now we apply to a function y. So we'll have d plus 1 first, and then derivative of y plus 3y. And now we multiply it out like distributive derivative of dy. So we have d squared y, and then d of 3y, and then dy, and then 3y. So that of course second derivative of y. Here we can take the 3 outside, and we have 3 times derivative plus 1 more, so that will be 4 times derivative of y, and then 3y. And then 3y. Of course, factor out the y, we have exactly that. Just say it. And that of course exactly that. Now so that d plus 3t times d is not equal to d times d plus 3t. Of course, if we multiply it out, if we treat d as a variable, it will not be correct. Now let's look at the left hand side. D plus 3t dy. Right. Now when we multiply it out, we have d squared y, which is second derivative, plus 3t dy. Right. So the left hand side is going to be like that. What is the right hand side? Right, so first we have derivative, and then we have dy plus 3ty. Right. Now we will take derivative of this. Remember, d is not a variable, d is a derivative. It's like an operator. So we have applied that. So the first thing is to find second derivative. But then we apply this to 3t and y. Notice that this work for a constant. We can take it outside. But since there is a variable here, this is the product rule. So we will have this square y plus derivative of the first one, 3 times y. So yeah, that derivative of the first term times y. And then the first term with derivative of the second. And of course they are not the same because of the difference in 3y. So yeah, so when we do that, we from right to left because the derivative applied to a function, then just keep going like that. So those two are different. It will be the same if they're just constant. Yeah, but if there's a t in here, be mindful with that. There might be a product rule like that. Now let's rewrite this equation using differential operators. So that should be easy. Second derivative, first derivative, and this is the function by itself. I just move to the other side. There's no y here, so just write like that. Yeah, if we want to, we can just factor out y. We have d squared plus 3d y equal to negative 6 sine t right, just like that. And then here we have, that is the second derivative, 3t, the first derivative, 5y equal to e to the t. And then of course we can factor out y. That's what we have. Right. In chapter 6, we use this for something else, but for now, we'll use this to show the system of differential equation. Let's say we have this system of equation. Derivative is equal to x with respect to t is that. Derivative of y with respect to t is that. So first thing is we will write this using the operator, the differential operator. So derivative is d of x. 3x move to the other side becomes negative. 4y move to the other side becomes 4y. Y prime dy minus 4x on the other side plus 7y on the other side, then 10t. So we have the system differential equation given in that form. Now both of these have x. We can factor out. We have d minus 3x plus 4y equal to 1. And then both of these have y. Factor it out. We have negative 4x plus d plus 7y equal to 10t. We write like this. So we have the column of x, column of y. Now what we do is we do the elimination. So either eliminate x or eliminate y. So let's say we multiply the top equation by 4 and the bottom equation by negative d minus 3. So we do that on both sides. We have 4 d minus 3x plus 16y equal to 4. Multiply on both sides. And then we multiply this in front of both of them. We have negative 4 minus d minus 3 x sorry, that should be a plus. Yeah, because it has a minus already, we just need to multiply by a plus. So that will be becomes negative here. And then we have d minus 3 d plus 7 y equal to derivative d minus 3 of 10t. So we take derivative of 10t and then minus 3 times 10t. Right. After that, what we do is we're going to add side by side. The reason we multiply 4 and d minus 3 because those will cancel out. On the left hand side we have 16y plus d minus 3 times d plus 7 times y, and then derivative d of 10y, and then 3 times 10y, and then plus 4. Right. Now we multiply it out. Derivative of 10t is going to be 10 plus 4. That's why the 14 coming from. So derivative, this is 10 and this is 4 together give us 14 minus 30t. Combined like term we have this. Of course, when we write like this, this system of this equation is second derivative plus 4y prime, I forgot, sorry, that's a typo here, minus 5y equal to negative 30t plus 14. Homogeneous equation, we have that, and we have the complementary solution. Particular solution, since it is in this form, we will guess that the solution is at plus b, take derivative, and the second derivative. Sorry. Yeah, I just copied and pasted and forgot to change. So, yeah. The guess solution is at plus b, derivative is a, second derivative is 0. Substitute back, and we solve for it. We have a is equal to 6 and b is equal to 2. So the particular solution is 6t plus 2. So put together we have y equal to complementary solution plus particular solution, and this is what we have. So we solve for y. Now to solve for x, there are two options. The first one is elimination. So we do the same thing. Here, instead of eliminate x, we try to eliminate y. So we multiplied negative d plus 7 on the top and 4 at the bottom. Something like that. Add side by side. And we'll do that, and we will have the function is equal to in this form. Yeah, it will take some time. And after that, of course, we write k1, k2, because if we write c1, c2, those will be the same. So we have to do that. Now, note that k1 and k2 are different. But if we substitute into this equation, I just pick the first one. And when we do that, matching both sides, and this is what we have. Now, since this is equal to 0, this has to be equal to 0, and this has to be equal to 0. So we have k1 is 1/2 c1, and k2 is 2 c2, and then we put it back. This solution, where was that? Okay, here, sorry. Put it in there, and we have x is equal to 1/2 c1 e to negative 5t plus 2 c2 e to the t plus 8t plus 5. Notice that this is two equations of two variables, and so we need, those should be just two parameters here. Right. Of course, that's complicated. Another way to do this is more direct. If we have the system of equations like this, we can substitute in either one of them. Now we have y, now we just need to solve for x. If we have to solve for x, the second equation looks easier to solve for, because the second equation we only have x here, we don't have x and derivative. If we have to substitute in the first equation here, we still have derivative and the function. But if we substitute in here, we just solve for x, and we do that, and we have the same thing. once again, take y, which is this function, take derivative, and then put it and the function into this equation, and we solve for x of t is equal to that. Okay. Let's look at the first example. Now, so the system of equation, derivative of x is equal to 4x minus y, derivative of y is equal to negative 4x plus 4y. Toward the end of the class, we have a different way to solve for this, but this time we use elimination. So first I will rewrite this as using the operator d, different notation. So derivative with respect to x, I move the 4x to the other side, minus 4x. Move the y to the other side as well, equal to 0. Now, do same thing for the second equation. Y prime, that will be dy, minus 4x to the other side, plus 4x. And then minus 4y equal to 0. Right? Now, let's just factor out the x. We have d minus 4 times x plus y equal to 0. Now this we just have 4x. And then factor out the y. Factor out the y here. Now, here we can have two options: eliminate x and solve for y, or eliminate y and solve for x. Let's eliminate x and solve for y. So from this one, we try to eliminate x. So let's just write out the step. We want to eliminate x and then solve for y. So I will rewrite the equation. The system of equation. Right. Now we try to get the same coefficient, so I can combine side by side to eliminate x. So to eliminate x, we'll have the d minus 4 from the bottom and the 4 on the top, so they will have the same. But let's try to throw the negative here. When we do that, we just have negative 4. Notice that when we multiply this, we multiply that in front. Uh, 4y negative 4 times 0, still 0. And then this we multiply by d minus 4. So 4 d minus 4x plus d minus 4y, d minus 4 times that square y. And then d minus 4 times 0. This is not actually times 0, it is derivative. So d minus 4 of 0, meaning we take derivative of 0 minus 4 times 0. Of course, the derivative of 0 is still 0. 4 times 0 is still 0. So that's just 0. Now we can add side by side. That gives us a negative 4y plus d minus 4 square y equal to 0. Right. Now multiply this out and combine with negative 4y. So we have negative 4y plus d minus 4 square will be d square minus 8d plus 16 y equal to 0. And multiply this out. Negative 4y d square y minus ADY plus 16y equal to 0, and combine negative 4y and 16, that gives us 12. And now we can rewrite this d square is the second derivative of y, a times the derivative, that gives us 12. And from here, of course, we get the auxiliary equation and then we solve for it. That should be easy, right? So auxiliary equation r squared minus AR plus 12 equal to 0. Factor out, factor this, we'll have r minus 6, r minus 2 equal to 0. So we have r equal to 6 and r equal to 2. And of course, y equal to c1 e to the 6t plus c2 e to the 2t. Right. So we have that. Of course, we could do the same thing, eliminate y and solve for x. But since we have y already, now just substitute this back and solve for it. Now, if we have to solve for x, which one is easier to solve for? Well, if we have to substitute it back, knowing y into this to solve for x, I will go with the second equation, because the second equation will only have the derivative. Here is x. So let's say it. Right. So second step, we substitute y equal to c1 e to the 6t plus c2 e to the 2t. We substitute that into this equation to solve for x. Now we have derivative and we have the function, so we need to take derivative first. Derivative, if this is going to be c1 6 e to the 6t plus c2 times 2 e to the 2t, so we have 6c1 e to the 6t plus 2c2 e to the 2t. Right. So this is the second derivative. This is the derivative. We go right here, and this is the function. We go there. Right. So substitute in that. So we have derivative 6c1 e to the 6t plus 2c2 e to the 2t equal to negative 4x plus 4 times y. The function is that. So multiply it out, 6c1 e to the 6t, 2c2 e to the 2t, negative 4x. Multiply this out, 4c1 e to the 6t, 4c2 e to the 2t. Right. I'm going to move the 4x over and move the 6 c1 e to the 6t and 2c2 e to the 2t to the other side. So let's move this to the other side, the 4x to the other side. right? So we do that, those cancel out, we just have 4x on this side. That cancel out, and that gives us 2c1 e to the 60 plus, wait, that is minus 2c1, and then we have plus 2c2 e to the 2t. Divide everything by 4, so x equal to negative 1/2 c1 e to the 60 divided by 4, so plus 1/2 c2 e to the 2t. Yeah. So we have x and we have y. Yeah. So we have x equal to negative 1/2 c1 e to the 60 1/2 c2 e to the 2t. Y equal to c1 e to the 60 plus c2 e to the 2t. Right. I highly recommend that we will substitute this into the other equation too, to check, to make sure that it actually works. So I will do that. So we have derivative of x equal to 4x minus y. Right. We test using that equation. So derivative of x, derivative of this, take down the 6, we have negative 3 c1 e to the 60, take down the 6, because that's the chain rule, negative 3 c1 e to the 60, and then this, the same thing times 2 and 1/2 cancel out, we just have c2 e to the 2t. So that is the derivative. 4 times the function c1 e to the 60 plus 1/2 c2 e to the 2t, and then minus c1 e to the 60 c2 e to the 2t. Yeah, just substitute into this equation, make sure it actually works. 3 c1 e to the 60 c2 e to the 2t, multiply this out, that's negative 2 c1 e to the 60 and plus 2 c2 e to the 2t minus c1 e to the 60 plus c2 e to the 2t. Wait, this is minus y, right? So that's minus. Right. And now that it checked, because this side we have negative 2, negative 3, that gives us negative 3, so that's good. And then we have 2 and minus 1 give us 1, so that check as well. Yeah, so I think this elimination, if we work, certainly we check for both equations, that certainly works. So in that case we don't have to eliminate x and solve for y. That sounds like a lot of work there, but that's what we do. Eliminate x, solve for y, or eliminate y and solve for x, and then the rest we could use elimination or substitution. I use a substitution there, and I actually check with the other two, the other equation too. So that's we guarantee to work. Right. Now, so this initial value problem. So when we have an extra initial condition, we will solve for that first, where we have c1, c2, and then at the end we solve for the initial condition. Alright, now first let's just say we eliminate x and solve for y. Let's do the same thing. So first step, eliminate. Try to write small because this problem look complicated. Yeah. Eliminate x, solve for y. Right, I will write very small and try to use all the space. Derivative of x, that dx minus y equal to t. Second equation, x minus dy equal to 1. Right, good thing is we do not need to factor anything because there's just an x, there's just a y there. So now we just eliminate x. So to get x, we will multiply a d from the, to the bottom. Dx and dx cancel out. So in that case, let's multiply negative d on the bottom equation. The top will stay the same. Dx minus y equal to t. And then this will have negative d x and d, negative d times negative d, that plus d square y, and then we have negative d up 1. Notice that it is not d times 1. We cannot just have the operator by itself. It is the operator, so derivative of 1. So this says derivative of 1, which is 0. So let's just rewrite this as dx minus y equal to t, negative dx plus d square y equal to 0, because derivative of 1 is 0, negative still 0. Now we add side by side. Dx cancel out, we have d square y minus y. Yeah, we just add side by side. Negative y plus d square y equal to t. Right. Of course, we will rewrite this equation. That will be equal to second derivative minus a function equal to t. The problem is this is not a homogeneous equation. This is, we have t here. So like I said, since we need some space, I will try to find as small as possible and take all the space we can have. So for this equation, we will have say 1a. For this, we have the complementary solution. So that gives us r squared minus 1 equal to 0, because homogeneous, that equal to 0, right? Yeah. Homogeneous equation, double y double prime minus y equal to 0, which gives us auxiliary equation r squared equal to 1. So r equal to plus or minus square root of 1, which is still plus or minus 1. So if that, so the complementary solution y1 equal to e to the t, y2 e to negative t, and complementary solution is equal to c1 e to the t plus c2 e to negative t. So that is complementary solution. Second, particular solution. This is not as bad. Now, we have this. The guess is going to be a polynomial of the first degree. So we will guess this will be in this form. Will that cover the t, right? Because that's the same degree as t. Right, to take derivative. Second derivative. And then substitute into this equation. So this equation becomes y prime, that will be 0, minus the function equal to t. Yeah. So I have negative at, negative b equal to t. Of course, when we see this, the coefficient of t have to match and the constant have to match. So this is obvious. So negative a is equal to 1 and b is equal to 0 because there's no constant on this side. That should be 0. Both of them have a t on each side. So negative a is equal to 1. So a is negative 1 and b is 0. And y particular solution at plus b, where a is negative 1, so negative t. Right. With that, the general solution y equal to complementary solution plus particular solution. Complementary solution is this, and particular solution is negative t, so that's all we have. So we have y. So eliminate x and solve for y. That's what we have for y. Now to solve for x. Yeah, how do we solve for x? Yeah, we can substitute into this equation or that equation, and we choose this equation because we just have x here. Right? So substitute. Now if we substitute this into this equation, x minus y prime equal to 1. Right, so just have, since x equal to negative y, x minus y prime equal to 1. So x equal to y prime plus 1. And I just take derivative and substitute in here. So derivative of this is c1 e to the t. Derivative of this is negative c2 e to negative t. And derivative of negative t is negative 1. And then just plus 1. Right. Remove the parentheses, that cancel out. We have x is equal to c1 e to the t minus c2 e to negative t. Yeah, 1 and 1 cancel out. So x equal to c1 e to the t minus c2 e to negative t. Right. Now, next is we have the solution x and y. Now we just need to solve for c, the coefficient, the constant, because we have the initial condition. So next, step number 3 is solving the initial condition. There are two of them. X of 0 is equal to 2, and y of 0 is equal to 1. X of 0 equal to 2, so I will put 0 in here and equate that to 2. So c1 e to the 0 minus c2 e to negative 0 equal to 2. E to the 0 power is 1. So we have c1 minus c2 is equal to 2. Same thing for y. Put 0 in for t. C1 e to 0 plus C2 e to negative 0 minus t minus 0. That will equal to 1. So e to 0 power once again is 1. So that's 1. So C1 plus C2 is equal to 1. Right. Now we have the system of equation. We just, this one is simple enough, so we just do that by hand. Yeah, just add side by side. C2 cancel out. We have 2C1 equal to 3. So C1 is equal to 3 halves. And now it's easy. We can just substitute in either one of this to solve for C2. Yeah, so we do that. Let's substitute back in here. We think I did that in pencil. To do that, we have 3 halves minus C2 equal to 2. Move the C2 over, we have C2 equal to 3 halves minus 2, which is negative 1 half. Now we have C1, we have C2. Substitute into these two equations. X equal to C1 negative 1 half e to the t minus C2 3 half e to the negative t. Y equal to C1 3 half e to the t minus C2 is negative 1 half. Okay. Yeah, let's just write the y first. 1 half e to negative t minus t. Right. C1 is 3 half. And C2 is negative 1 half. C2 is negative 1 half with an extra minus, so that's a plus 1 half. Yeah, so this is 3 half e to t plus 1 half e to negative t, and y is equal to that. Now the good thing is we still have the other equation that we haven't used. It's good to check, right? So we have this equation. What we did to solve for is we're going to substitute in this equation. Now we use x prime minus y equal to t. I just need to make sure that works, because there are two equations. Just make sure it works. Derivative of x, derivative of that is going to be c1 e to the t, and that will be extra negative, so that plus c2 e to the, sorry, we do have the solution here, so let's write that again. X prime minus y equal to t. Right, x prime, derivative of this, 3 half e to the t minus 1 half e to minus t. Subtract y. I'm just going to copy the whole function there. And is that equal to t? So yeah, 3 half cancel out, negative, that plus, negative, that plus. So that's good. Yes. So let's check out. Negative. Yeah, so we have cancel this out, t equal to t. Yeah, so that check. So the point here is we rewrite the system equation using the operator D and do the elimination. Either eliminate X and solve for Y, or eliminate Y and solve for X. In the homework on my math lab, since they want to simplify things, they just want to establish, I think they should just tell you to eliminate X or eliminate Y. Just follow that. And when in this case, when we eliminate that, it's happened that we have a non-homogeneous equation. So in that case, we have to have is 1A and 1B. 1A for the complementary solution, 1B is particular solution. That 1B and 1C. And particular solution and general solution is that. So yeah, so this equation by itself is very easy to solve for. So that's what we have for Y. Now to solve for X, I could put it back in this equation or that equation. I would choose the second equation because this I just have the function by itself. Just move the Y prime over, and that's pretty much it. And that's exactly what we do. And this we solve for X, and that's what we have. This problem we have the initial condition as well. So we use that initial condition. We solve for C1, solve for C2, and then substitute back into the equation. We have X and we have Y. Just make sure that it works. We take this solution, put it back into the equation that we have in use, and let's check out. So what the solution we have is correct. Right. So it's not that bad. It could be a bit tedious, depends on when we do the elimination. If the equation is more complicated, then we require more work. But in this case, it's not as bad. But if we have the initial condition, substitute back and find all the constant. So if we have initial condition, there will be no constant in here. By constant I mean C1 or C2. Anyway, I stop this section here. As always, thank you for watching and see you in another video in differential equations.